About 13.8 billion years ago, our universe was born. This momentous event marked the beginning of everything we know, from the smallest particles to the vast galaxies that stretch across the cosmos. It all started with a singular, incredibly dense and hot point, often referred to as the singularity. Imagine everything squeezed into a tiny point smaller than an atom. This point contained all the matter and energy that would eventually form stars, planets, and even life itself. The conditions were so extreme that our current understanding of physics can barely describe them. This was the singularity, a place of unimaginable density and heat. Temperatures soared to billions of degrees, and the forces at play were beyond anything we can experience on Earth. It was a state of pure potential, waiting to unfold. Then, the Big Bang happened. In an instant, this tiny point began to expand, releasing an incredible amount of energy. This wasn't an explosion in the traditional sense, but rather an expansion of space itself, causing the universe to grow exponentially. It wasn't an explosion in space, but an expansion of space itself. As space expanded, it carried galaxies, stars, and planets along with it. This expansion set the stage for the formation of all the structures we see in the universe today. The universe rapidly expanded and cooled. In the first few moments it was a hot, dense soup of particles. But as it expanded it began to cool, allowing particles to combine and form the first atoms. This cooling process was crucial for the development of the universe as we know it. In a fraction of a second it grew from subatomic to astronomical. This period of rapid expansion is known as inflation, and it helped to smooth out any irregularities in the early universe, leading to the relatively uniform cosmos we observe today. This rapid expansion continues to this day, though at a slower pace. The universe is still growing, and galaxies are moving away from each other. This ongoing expansion is a key piece of evidence for the Big Bang theory. The Big Bang is the foundation of our understanding of the universe, explaining how everything came to be. From the tiniest particles to the largest galaxies, it all started with that singular moment of creation. As we continue to study the cosmos, we uncover more about our origins and the incredible journey of the universe. In the first few seconds after the Big Bang, the universe was incredibly hot and dense. It was so hot that matter as we know it couldn't exist. Instead, energy dominated, with particles constantly colliding and transforming. As the universe expanded, it cooled. This cooling allowed energy to convert into fundamental particles like quarks, electrons, and neutrinos. These particles would eventually become the building blocks of everything we observe in the universe. The universe continued to cool, and particles began to combine. Around 380,000 years after the Big Bang, the universe cooled enough for protons and electrons to combine. This formed the first atoms, primarily hydrogen and helium. This event, called recombination, was crucial. It transformed the universe from an opaque plasma into a transparent state. This is when light could finally travel freely, giving us the first glimpse of the early universe through the cosmic microwave background radiation. After the formation of atoms, the universe entered a period called the Cosmic Dark Ages. It lasted for millions of years. During this time, gravity began to pull matter together. Dense regions of mostly hydrogen and helium gas started to form. These clumps of gas grew larger and denser, eventually collapsing under their own gravity. This collapse caused the gas to heat up tremendously, reaching temperatures high enough for nuclear fusion to occur. This marked the birth of the first stars. Section 5. Islands of Stars. The first stars were massive and short-lived, but their formation was a turning point. They flooded the universe with energy and heavier elements. These elements, forged in the cores of stars, would later become the building blocks of planets and life itself. As more stars formed, gravity pulled them together into vast collections called galaxies. Our own galaxy, the Milky Way, formed around this time about 13.6 billion years ago. It's a massive structure containing billions of stars, gas, and dust. Section 6. Birth of our Sun. About 4.6 billion years ago, in a spiral arm of the Milky Way, a giant cloud of gas and dust known as a nebula began to collapse. This nebula, rich in hydrogen and helium, was the remnant of previous generations of stars that had lived and died, scattering their material into space. This collapse triggered the formation of our solar system. As the nebula contracted under its own gravity, it began to spin, forming a flattened disk with a dense core at the center. At the center of the collapsing nebula, gravity pulled most of the material inward. This central region, known as the protostar, continued to gather mass and heat up. This central mass became so hot and dense that nuclear fusion ignited, giving birth to our sun. Nuclear fusion is the process where hydrogen atoms combine to form helium, releasing immense amounts of energy in the form of light and heat. The Sun, a yellow dwarf star, contains about 99.86% of the total mass of our solar system. This massive star exerts a gravitational pull that keeps the planets, asteroids, and comets in orbit around it. It's the powerhouse that provides light and heat essential for life on Earth. The energy from the Sun drives weather patterns, ocean currents, and supports photosynthesis, the process by which plants produce food. Without the Sun, Earth would be a frozen, lifeless rock, drifting through space. The Sun's surface is a dynamic place with solar flares and sunspots indicating intense magnetic activity. These phenomena can have significant effects on space weather, impacting satellite communications and even power grids on Earth. As we continue to study the Sun, we gain a deeper understanding of its vital role in our solar system. From its formation to its ongoing influence, the Sun remains a source of wonder and a key to life as we know it. Section 7. A disk of dust and gas. While the Sun was forming, the remaining material in the nebula swirled around it, creating a flat, rotating disk called a protoplanetary disk. This disk contained gas, dust, and ice particles. Over millions of years, particles within the disk collided and stuck together. This process, called accretion, gradually formed larger and larger objects. Small particles grew into pebbles, pebbles into boulders, and eventually boulders into planetesimals, the building blocks of planets. Section 8. The third rock from the Sun. In the inner region of the protoplanetary disk, where temperatures were higher, rocky planetesimals collided and merged to form the inner planets: Mercury, Venus, Earth, and Mars. Earth, located about 93 million miles from the Sun, found itself in the habitable zone. This zone is the perfect distance from a star where temperatures are just right for liquid water to exist on a planet's surface. Liquid water is crucial for life as we know it, and its presence on Earth played a vital role in the emergence of life. Section 9. A cosmic perspective. The journey from the Big Bang to the creation of Earth is a story of cosmic evolution spanning billions of years. It all began with an unimaginable explosion, a singular event that set everything into motion. This explosion, known as the Big Bang, marked the birth of our universe. In an instant, all the matter and energy that would ever exist was created, and the universe began to expand at an incredible rate. From a single point, the universe expanded and cooled, giving rise to particles, the fundamental building blocks of everything we know. These particles began to combine and form atoms, the simplest units of matter. Over time, these atoms came together to form stars, the brilliant beacons of light that illuminate our night sky. Atoms, stars, galaxies, and planets. Stars gathered into vast collections known as galaxies, each containing billions of stars. Within these galaxies, stars and planets formed, creating the diverse and dynamic universe we observe today. Earth's formation was a culmination of these cosmic events. Our planet formed from the remnants of previous generations of stars, which had exploded and scattered their enriched contents across space. These materials coalesced under the force of gravity, eventually forming the Earth. Our planet is a result of the intricate interplay of gravity, which pulled together the dust and gas to form solid bodies, and nuclear fusion, which powered the stars and created the elements necessary for life: nuclear fusion and time. Over billions of years, these processes have shaped the universe, creating the conditions necessary for life to emerge on Earth. Understanding this journey gives us a profound appreciation for the vastness of the universe and our place within it. It allows us to see the bigger picture, to understand that we are part of something much larger than ourselves. The universe is vast and ancient, and our existence is just a tiny blip in its grand timeline. It reminds us that we are all connected to the cosmos, born from the same stardust that formed our planet and everything on it. This cosmic perspective can inspire a sense of wonder and curiosity, encouraging us to explore and understand the universe we inhabit. It is a humbling reminder of our origins and our place in the grand scheme of things.